In this tutorial, I will show you how to open a concrete ETABS model in ConcDetailer, define main beams, shear walls, perform code checking, and generate detailed drawings. ConcDetailer is an auto-generated software for concrete building drawings. It reads design output of concrete buildings modeled by ETABS, ensures compliance with design codes, and generates final drawing in AutoCAD script files. Working with ConcDetailer is very simple and straightforward as these three steps. First, we should export our ETABS model to .e2k and concrete design result to .text file. Then open these files in ConcDetailer, define main beams and shear walls. The program performs code checking and generates the detailed drawing file. And finally, we open our script file in AutoCAD. To open the model in ConcDetailer, we must generate two files from ETABS model. One file with extension of E2K and another one with the extension of TXT. The file with extension of E2K contains the model information and it can be generated through File, Export, ETABS.E2K text file. Another file with extension of TXT contains the concrete results of the model and it can be generated through File, Export, ETABS database tables to text. To open the file, click Open button, choose the desired file with extension of E2K and click Open. The file will open. For the first time opening the model in ConcDetailer, we should define the continuous beams. To do this, I can select Define Continuous Beam button from the toolbar menu. To define the first continuous beam, move mouse to point A1 and press left click of mouse. Continue defining other points of the continuous beam by left clicking points B1, C1, D1, and E1. To finalize the selection of this continuous beam, right-click and the program will display the first defined continuous beam, named CBeam1, in the plan view. Define additional continuous beams using the same process. The All Stories option is selected by default in Similarity combo box. Consequently, ConcDetailer will generate all continuous beams across all stories. To define the beam's pattern of bars, I click the Pattern of Bars button in Toolbar. In this form, enter 3 number of 20 mm bar size, 3T20, as main bars and 20 mm bar size, T20, as added bars of all stories except the roof. Next, choose the known options in first the combo box of Similarity grid box. Then select story 6 and select 3T18 for main bars and T18 for added bars of roof story. I click the OK button to close the form and the program will verify the intermediate moment frame clauses of ACI 3.19.19 for the current project and report any clauses that have conflict. If the conflicting clause items can be corrected by ConcDetailer program, the program will automatically make the necessary corrections. Corrected items will be displayed at the end of codes clause, and no modification in ETABS model by the user will be necessary. Define shear walls by clicking the Shear Wall button in the toolbar menu. Depending on the shear wall shapes, there are several cases for defining shear walls. In the first option, the entire core walls can be defined as 4 linear walls. In the second option, it can be defined as a U-shaped wall and a linear wall. For the current project, the second option is selected to demonstrate how a 3-dimensional shear wall can be drawn as a linear wall. To do this, left-click on the points of C3, C2, D2, and D3. And then right-click with the mouse to define SHW1. Repeat the same procedure to define SHW2 by clicking on the end points of shear walls between X, C, and D. Note that shear walls will be generated for all story scenes. The All Stories option is activated in Similarity combo box. To exit from draw mode of shear walls, press again the shear wall button again. Define the reinforcement of shear walls by clicking the Reinforcement of Shear Walls button in Toolbar menu. In this form, you can define the thickness of shear walls as well as the size and spacing of reinforcement in two directions. To define reinforcement of slabs, click the Slab Design button, Toolbar menu. In this form, choose the size and type spacing of main bars of the slab and the size of added bars in two directions. For main bars, define T14 at 200 mm, and for the added bars, select T14, then press Apply button. ConcDetailer will display a diagram illustrating the required area of bars, the area of main bars, and calculate and show the number and size of added bars for any location of the strip if they are needed. To define the length, numbers, and configuration of added bars in drawing, click the OK button and click the Slab Detailing button in the toolbar. In the Slab Rebars Details form, choose the CSA3 strip that requires additional rebars. In the Added Required Rebars group box, the number of added T14 rebars in the start, middle, and end parts of span 1 will be displayed as 2, 0, and 12, respectively. To assign the first group of added bars to the start location, select T1 options in a Location group box. Enter a length of 2 meters for these two T14 added bars and press Apply button. The selection of bar length is based on the code required length while minimizing the waste of bars during the cutting process. Based on the ACI 315R18, the length of top bars should be at least 1/4 of the clear span length for the added bars in the start location of first span and 1/3 of the clear span length for the others added bars. The clear span is 6.7, subtract 0.4 equals 6.3 meters. Therefore, for the start location, we can take a length of 6.3 divided by 4 equals 1.57, which is equal 2 meters. And for other locations, 6.3 divided by 3 equals 2.1, say L is equal 3 meters. Note that ConcDetailer will distribute these two added bars on both sides of the longitudinal strip, as indicated by 1T14 at 100 mm on the left and right side of the section. Repeat the same process for the assigning 12 added bars at the end location of span 1 by selecting the T options in the Location group box, entering 3 meters for the length, and pressing Apply. We should repeat this process for other spans of the strips of layer B. To generate the detailed drawings for AutoCAD, click the Run button in Toolbar. In the Run form, to generate specific drawings such as columns or beams, select the corresponding checkbox. To generate all drawing, simply click the All checkbox. In the Drawing group box, additional selection options are available to customize the final drawings. Upon pressing the Run button, the list of bars form will be displayed, presenting a list of lengths, members, and weight of bars. These details can be presented for a specific member type, such as columns, beams, shear walls, or slabs, and can be shown for a selected story. The table includes information such as total weight of all bars, area of each story, or total area of all the stories, and the weight per square meter of used bar. The weight of bars per unit area of building is a dimensionless parameter that can be compared to other projects. This parameter serves a useful indicator providing an estimation of the economic or even safe design. It's important to note that the current project is a tutorial project and has not undergone an optimum design. By pressing the End button, the ConcDetailer program will generate all final drawings in an AutoCAD script file with the same name as the project name with the extension of SCR. To open the file in AutoCAD program, type the script command in command line and select the desired file in the Open forum. The script file will be executed and all drawings will be generated in AutoCAD. After completing the drawings, they can be saved as a DWG file.